Good morning. Today is Friday, May 22nd, and we're going to talk about experimental probability today. So, what is experimental probability? Well, experimental probability is a probability that is based on repeated trials of an experiment. This is what actually occurs during an experiment. We have to record results of what is happening. We don't know what's going to happen. We have to do an experiment repeated number of times, record the results, and then determine the probability based on those results. So it is what actually happens instead of what you were expecting it to happen from what we were talking about yesterday. Okay. So here's an example. So the graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Okay, so just to kind of wrap your brain around this. So I have a spinner, okay, and I have a green section, I have a blue section, and then I have a red section, okay, and I spin the spinner. Okay. And it landed on green. I did an experiment. I spun it 60 times. It landed on green 21 times. That's why I have a bar graph, the bar going up to 21. Okay. I spun the blue, landed on blue 15 times. I recorded that. And then the red, it landed 24 times. So what we want to do is find the experimental probability of spinning red for this experiment. Well, spinning red for, like, if this was theoretical, would be 1 out of 3, right? But I want to know what the experimental probability is. So remember, the number of favorable outcomes, that is what goes on top, and the number of possible outcomes is what goes on the bottom. So again, the probability of spinning red, I have 24 red spins out of the total of 60. Where did I get 60? Well, it tells us in the problem, but you could have also added 21 plus 15 plus 24. That gives me 60. Okay, so that's the 60. That's my total possible. And the number of favorable outcomes, what I want to have happen, that's the 24. Okay, can that be reduced? Yes, that can be reduced to 2/5, which is about a 40%. How did I get that percentage again? Well, I take 2 divided by 5. That gives me 0.4. To change that to a percent, I move it over 2 spaces. And so that's 40% chance of happening. Okay, so that's my experimental probability of spinning this spinner. And if you remember, I drew that spinner, all right? I drew that spinner with 3 sections, and I labeled this one green, I labeled this one blue, and red. If this was the theoretical probability, spinning a green would be a 1 out of 3 chance, which is about a 33.3% chance. All right, so this would have been my theoretical probability, and this is my experimental probability. So they are different. Okay, but for today, we're talking about experimental probability. So here's another example. A spinner is divided into 4 equal sections and it's spun 100 times. So it's telling me I spin it 100 times and it lands on green 32 times. Okay, so I have 4 equal sections on the spinner here and it lands on the green 32 times. Okay, and what is the experimental probability of spinning green? Well, 32 out of 100, because 32 is what I want to have happen out of the 100 total possible spins, that can be reduced to 8 out of 25. And if you're unsure of why it's reduced to 8, you can divide the top, the numerator, by 4 and the denominator by 4. So you get 8 out of 25. Okay, so how can I make this a decimal? Well, you take 8 and divide it by 25. And when you do that, you get 0.32, which is a 32% when you move your decimal point over 2 spaces to the right. Okay, let's take a look at another one. So here's a table. This table shows the sales of books in different subjects. And if you look here, I have math has 44 books that were sold, English was 36, zoology is 24, and physics was 25. So it's asking you, what is the experimental probability that the next sale will be a zoology book? Well, how many total books do we have here? Well, we have 129. If you add it up, 144, 36, 24, 125, you get a total of 129. All right. And there's 24 zoology books. So can I reduce that fraction? Yes, we can. If you take a 3 out of both, you will get an 8 out of 43. So what is that as a percentage? Well, that's about an 18.6%, because if you take the 8 and divide it by 43 in your calculator, you'd get 0.186, move it over twice, and you get an 18.6%. So it's an unlikely that the next zoology book will be the one that's going to be sold. Okay, thinking about yesterday when we had our spectrum of 0% would be uncertain, 100% would be certain, 50% would be unlikely to likely, So this would be the 25%. That would be unlikely that would be the next book that would be sold. Okay. All right, so let's take a look at another one. An experiment consists of spinning a spinner. Use the results in the table to find the experimental probability of the spinner not landing on green. If you remember yesterday, we talked about the complementary events, and sometimes that word "not" is not bolded or underlined or emphasized. So be careful to make sure you're looking at what is not green. So if you look at if you add up all of the color choices, you do have 40 choices. So 15 plus 10, 15 plus 10 plus 8 plus 7 does give you 40. That's your total number is 40. And to not have green, well, you can take 40 minus 15 or just add up the 10 plus 8 plus 7, which does give you the 25. So 25 is orange, purple, or pink, which means that's not green, out of the 40 total. Can that be reduced? I hope you said yes. You could take a 5 out of both and you get 5/8. So the probability of the spinner not landing on green is 5 out of 8, which is a 62.5% chance, which is likely to happen. Okay. And again, why is this called experimental probability? Because we had to do an experiment. We had to write down the results and we had to calculate what the probability of each one of these is to happen. All right. So this is something a little different here. We're going to use probability to make a prediction. All right. So we're going to use something that we talked about probably back in October, November-ish, to help us to make a prediction based on the probability. So today you attempted 50 free throws and made 32 of them. You want to use experimental probability to predict how many free throws you will make if you attempt 75 of them. All right, so let's go back to the beginning. It says today you attempted 50 free throws and made 32 of them. So that would be our first probability, right? 32 out of 50. But I want to know how many you will make if you attempt 75 of them. There's a couple ways we can do this, but the way that we've taught it for a while here is to set up a proportion. You want to make a prediction about probability, you write a proportion. So if you remember proportion, we had a fraction equal to another fraction. And so I have the 32 out of 50 here. Okay, this was my first probability. So if I make 32 out of 50, I want to know how many out of 75 I will make. Okay, so 32 out of 50, and I want to know how many out of 75 it would be. Okay, so if you remember, what we taught was breadsticks, the way we taught it. Okay. So my first breadstick that I do, I had 32 times 75, and that gives me 2,400. And then 50 times x, which gives me 50x. And to get x by itself, you divide by 50, divide by 50. And what is 2,400 divided by 50? That should give you 48. So let me erase a little bit of this here. So x is 48 throws. So again, how does this, let's go back here. So it says, today you attempted 50 free throws and made 32 of them. So 32 out of 50 is the same as, is equal to how many out of 75? So setting up my proportion, I cross multiply, we do the breadsticks, we cross multiply, all right? And we will get 48 throws. If you want to check to make sure you're right, what you could do is take and divide each one of your probabilities here. If you take 32 and divide it by 50, you get 0.64. 0.64. And if you take and actually substitute in this 48 and for x, so you have, let me erase a little bit of this. So you have 48 out of 75. And if you take and divide that, you should get the same decimal. You should get 0.64. Okay. So that's one way to double check to make sure that when you cross multiply and when you substitute it back in, that should be the correct answer. Okay. That might have been over your head a little bit, but let's do another one. And the more that we do about these, the more that you will understand them. Okay, so last year, a DVD store sold 670 action DVDs, 580 comedy DVDs, 450 drama DVDs, and 300 horror DVDs. All right, so again, 670 action, 580 comedy, 450 drama, 300 horror DVDs. If a media buyer expects to sell 5,000 DVDs this year, based on these results, how many comedies DVDs should she buy? All right. So comedy DVDs is what? 580. So we have 580 comedy DVDs out of the total of how many? Not the 5,000 yet. It's 580 out of the total number of DVDs right there, which was the 670 plus the 580 plus the 450 plus the 3,000 or 300, sorry, which gives me 2,000. Okay, so 580 comedy DVDs out of the total number of DVDs. But we want to know how many comedy DVDs should she buy if we have a total of 5,000 DVDs. All right, so we're using probability to make a prediction. In order to make a prediction, we are using a proportion. Okay, so then we're going to cross multiply again. All right, so I'm going to do the 2,000 times x, which is 2,000x. And then I'm going to do 5,000 times 580. And I get a very big number here. I get 29 with 1, 2, 3, 4, 5 zeros. So that's 2,900,000. And then I'm going to divide both sides here by 2,000. Sorry for my sloppy writing. But dividing it by 2,000 will give you 1,450. All right. So again, what I did is we cross multiplied and divided and got 1,450. So 580 comedy DVDs out of 2,000 total. And I want to make a prediction. So how many comedy DVDs if there was 5,000 total? So when you cross multiply and divide, you'll get 1,450 comedy DVDs. And I don't know if writing out the units will also help you as well, where we have to have the same labels on your numerator as you do on your denominator. And another thing is you might be thinking, well, is my x always going to be on the top right side? Yes. Okay, you're making a prediction, so you want to know how many out of a total number. Okay, here's the next one. So Boris is in charge of planning a reception for 1,400 people. He is trying to decide which snacks to buy. He has asked a random sample of people who are coming to the reception what their favorite snack is. The results are in this table below. Okay. So based on this sample, predict the number of people at the reception whose favorite snack will be pretzels. And we want to round our answer to the nearest whole number. So we have 27 pretzels, right? Out of how many here, though? How many people were surveyed? Well, you want to add up the 34 plus 27 plus 58 plus 61. The total number of people here is 180. So we have 27 that like pretzels out of the 180 that were surveyed. So then we want to know how many people are going to like pretzels if 1,400 people were surveyed. All right. So then we can cross multiply here. All right. And 180 times x is 180x. And then 1,400 times 27 gives me 37,800. And then we want to divide by 180 to find my final answer. And 37,800 divided by 180 gives me my answer of 210. So 210 people will like pretzels if surveyed from 1,400 people. All right, so let me erase all that there. All right, so again, 27 people like the pretzels out of 180 people because I added up all of these and I got 180 total. 27 like pretzels out of 180. So how many out of 1,400? Well, we did the math and it was 210 people. Okay, so we are always setting up our proportion based on the probability to make a prediction. Okay, let's take a look at another one. All right, so if Brian spins the spinner below 48 times, how many times should he expect the spinner to land on the number 3? Well, there's only 1 3 out of the 8 choices, right? So then I put my equal sign, and then I need to set up another fraction, making a prediction. And I want to know if I did it 48 times. So I want to know how many out of 48. And when you do the math, okay, 1 times x is 1x. And then 8 times 48 gives us 380. Oh, my Lord. Let me go back here. Okay, so let's do that one more time. I messed up there. So 8 times x, that gives me 8x. And then 1 times 48 gives me the 48. And then I divide it by 8, and I get x equals 6. So my answer here would be 6 times. Okay. All right. Let's take a look at this next one here. This one's a good one. All right, the table shows the number of necklaces sold in 3 sizes and 2 different metals by a jeweler in January of 2018. If they had sold 100 necklaces in February 2018, about how many 20-inch gold necklaces would he have sold? All right, so this might help to see. Okay, so we're looking for how many 20-inch gold necklaces. If you look at this table here, I have silver necklaces and gold necklaces. And for each color of necklace, I have 3 different sizes. Okay, so it's asking how many 20-inch gold necklaces would he have sold? 20-inch gold. That's what I'm looking for. So that's 12 out of 75. And where did I get 75? Is because I added up all of the total number of necklaces here. So I have 12 gold ones out of 75 total here. Okay. And so what this question is asking, if they had sold 100 now, they only had sold 70. If they sold 100, how many would be 20-inch gold? Okay, well, if there's 12 out of the 75, how many out of 100 would there be? And in order to solve this, we are going to cross multiply. So we take the 12 times 100, and that's 1200. And then we take 75 times x, and that's 75x. Divide by 75. And what do we get? And what do we get when we take that? We get, I have answer choices here. I have 20, 12, 16, or 18. We end up getting 16. So 16 gold 20-inch necklaces if we sold 100. Okay. So again, what we did, when you cross multiply, you get 1200 when you take 12 times 100, and then you get 75x when you take 75 times x, take 1200 divided by 75, and then you end up getting the 16. Okay. If you need to go back and look at that one again, please do so. You will have a question very, very, very similar on your graded assignment, just like this question. Okay, so make sure you understand this. All right, now we're going to go through some checkpoint questions. I think there's about 5 of them here. I can pause for each one of these and give you a second to read them. So I'll do that for this first one here. So I'll give you a minute to take a look at this one. Okay, so it says last January, it snowed 7 days. It was sunny 18 days. It was cloudy 6 days. Based on this information, what is the probability that it will snow on a randomly chosen day in January? All right, well, there's 7 days, 18 days, and 6 days. That's a total of 31 days, right? And it says, how many will it snow? Well, snow's 7, so that's 7 out of 31. Okay. Well, get rid of that. Based on this, what is the probability? Well, it's 7 out of 31. Can I reduce that? The answer is no. But here's the question. Is this probability an experimental probability, or is that theoretical probability? Remember, experimental probability is you had to record results based on repeated trials of an experiment, and theoretical means that you know what's going to happen. So basically, did you know that it's going to snow 7 days in January? Or is it going to snow exactly 7 days in January every day or every year? No. So this is an experimental probability because results are recorded. Every January, this is not what is expected to happen. So this is experimental probability because somebody went and recorded results 7 days, 18 days, 6 days. It's not always going to snow 7 days in January. And again, that is about a 22.5% chance. Okay. Let's take a look at the next one here. And if you want to pause it, try to do this on your own and then come back, unpause it, and we can go through it. Okay, so a survey of Mrs. Ramirez's students showed that 30 students will have pizza for lunch, 17 will have macaroni and cheese, and 12 will have hamburgers, and 5 will have chicken fingers. Suppose that Mrs. Ramirez surveys all 1,200 students in the school. How many students will she expect to choose hamburgers for lunch? Okay, well, 12 chose hamburgers, right, out of the survey of how many students? Well, you have to add up the number of students that she surveyed, which was 30 plus the 17 plus the 12 plus the 5. And that's the 54 students. And how did I get that again? I added 30 plus 17 plus 12 plus 5, and that's 54. So I want to know how many out of 1,200 will she expect to have hamburgers for lunch? Okay, so let me erase that here. And you should get 225 students. And how we get that? Again, we can cross multiply, and you will end up getting 225 students. All right. This one was always a tricky one. I do like this question. It says, Dylan is playing pool with his friend. On the table, there are 7 solids, 7 stripes, and an 8 ball, which counts as neither a solid nor a stripe. So right there, you have 7 solids, 7 stripes, and an 8 ball. So you have a total of 15 balls on that pool table, okay? On the first show, one of the balls goes into a pocket. What is the probability that it is not a solid? So what do we think here? Well, there's 8 that are not a solid because you have 7 stripes and then you have an 8 ball. The 8 ball is not a solid nor a stripe. So it counts as 8, the 7 stripes, and the 8 ball. That means that there are 8 that are not a solid out of the 15 total balls that are on the table. So that answer choice then would be C. Right? A common choice that some people make a mistake on is choosing A is because they don't count that 8 ball. The 8 ball, which counts as neither a solid nor a stripe. Okay. Take a look at another one. So it says, what is the probability of the spinner landing on green? Well, how many choices do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 total slices of this spinner. And what is the probability of it landing on green? Well, there's 2 out of 8, right? 2 green out of 8, which that reduces to 1/4. So our answer choice is A. Okay, so 2 out of 8 is equal to 1/4. Okay, now here's another one. Last one here. A spinner below shows 10 equally sized slices. Jessica spun the dial 500 times and got the following results. Okay, here's her results. Assuming that the spinner is fair, what is the theoretical probability of landing on gray? Now, this is talking theoretical. Should I use the results of my experiment from the table, or should I use the spinner? Theoretical results means I should use my spinner. I don't look at the table yet. Okay. So assuming that the spinner is fair, what is the theoretical probability of landing on gray? Well, if we look at our spinner, we have 3 sections that are gray out of 10, and that's about a 30%. Okay. So now I have part B to this question. It says, from Jessica's results, what is the experimental probability now? Experimental. So the experimental probability, I am looking at the table now, okay? Because I'm looking at results. So looking at results, I want to land on gray. So that's 167 that landed on gray already out of the 500, okay? So how many then out of, so 167 out of 500, which then which then gives me a 33.4% chance. Okay, you might be thinking, can I simplify the 167 out of 500? And the answer was no. Nothing will go into the 167 and the 500 evenly. But if you want to make that into a percent, you take the 167 divided by the 500, and you'll get the 33.4%. Okay. If you need to go back and rewatch this video, please go for it. Make sure you understand the difference between experimental and theoretical probability. And I think that this question right here does help to explain the difference between the two. Again, theoretical probability is based on knowing what is going to have happen. You don't have to do an experiment. You know what's going to happen. An experimental probability is you have to do an experiment. You have to record results, and it's based on something happening over and over and over, repeated results of an experiment. Okay. If you have any questions, please email your teacher, stop into office hours every day from 11 to 11:30. All right. And again, enjoy this and have a